Hey, Dr. Sullivan here, and I want to just talk to you a little bit about evaluating the academic rigor of the task in your classroom. So I want you to think about. I've already had you look this over and think about the rows and columns, and so I hope you notice that the columns, if you focus on the columns, the concepts are the same. So the first column talks about multiples and common factors, and that's the concept. And then over to the next, we have area and perimeter, except for the last column there. I'm not sure what happened, or excuse me, the last cell in that column. And then on the far right, we've got the ideas of slope and y-intercept and those ideas. So, but I want you to focus for a little bit now. Let's just focus on what I want to focus on is the row. And let's start from the bottom here. Let's start with this row. And I'm going to start from the far right. So think about what you need to know to be able to engage, for students to engage and solve those problems. They need to be able to at least memorize that the slope is the coefficient of the linear term and the y-intercept is the constant term of that form. So they'll have to know that. Just like in the next one over, if I'm moving from right to left, think how many minutes are in 1 hour. They have to be able to memorize and already know that there are 60 minutes in 1 hour. If you don't know that, you can't engage in the problem. And then on the far left, it says use the terms factor, divisor, multiple product, and divisible given a statement. Again, you have to have associated meaning with those terms, otherwise you can't engage. So that's the lowest level of academic rigor, and that's considered memorization. So, think about your classroom and ask yourself how many of the tasks I give my students doesn't involve memorization. So the next row up here is, again, think about, let's go to the middle again and think about the mental activity the student would have to engage in to think about solving that problem. Again, in their back pocket, they've been given some dimensions and they have to be able to know the formula for the area and they have to know the formula for the perimeter of a rectangle. And if they know that, then they engage. But again, there's going to be an enacting of a procedure. They're going to substitute values in. They're going to perform that procedure. Just like on the far right, it says find the slope of the line. Again, they have to have in their back pocket a formula for computing slope and be able to substitute those points into that formula. So there's a little bit more of a mental work being asked of students, but there's a very clear procedure to follow, and they're being told explicitly what that procedure is. So for example, in this case, this row of tasks would be considered procedures without connections. It's very algorithmic, and it's just a rote procedure that the students have to enact. So let's go up to the third. Now it gets a little dicier. And so just think about the mental activity that a student would engage in as they solved those tasks. So if you compare, let's again go to the middle column, draw two different shapes with an area of 16 square units. What is the perimeter of each shape? And so in this particular case, they have to think about the idea that there's different possibilities here, and they're not having to compute right off the bat, but they're having to reflect on, they've been given an area and they have to figure out dimensions that would satisfy, of a rectangle that would satisfy that area. And so the other implied, I want to say an implicit connection is the idea that if you think about this, that we could have the same area of a rectangle and different perimeters. So there's a connection kind of implicit in the work. It's not specific, but it's there. The same with problem on to the right of that one. If you think about the leaking faucet, students are not being told explicitly what to do, but they also have to make some connections. And that connections is, if we really want to find 100 milliliters, we're going to have to figure out the slope and see if there's a constant rate of change going on as we do this. So they have to bring to bear. It's not implied, or excuse me, it is implied in the work that they're asked to do, but it's not explicitly telling them what to do. So that's the difference. At this level, we're talking about making explicit connections. And I encourage you to read the common characteristics of task at each level to get a sense of some of the what I consider the markers. For example, this task that involves more than one strategy and or representation, but does not require an explanation. Oftentimes, in these type of tasks, students aren't required to explain why or justify or compare. And if they are asked for an explanation, it's typically to explain their steps. So that's the third level. And then the very top again, think about the work that students have to do here to engage. In this case, they're given an area and they're given a perimeter, but it's not explicitly stated that it's an area and perimeter. They have to deduce that. And then they're being asked to sketch floor plans for that and communicate the meaning of the area and the perimeter. So there's a lot more work being asked for here. And in this particular case, the connections are being made explicit. So this is the highest level. Students are having to make decisions. And if we talk about the Smith-Sign framework, these could be considered doing mathematics tasks, and they may be also procedures with connections. But one of the questions I want you to reflect on as you think about these 4 levels is, when you think about the tasks that you give your students in a class, what level are they? I'm going to have you do an activity involving looking at one of your last assessments. And if you're going to characterize your last assessment, what levels would it be? So I just want to go on a little bit here, and I want to show you some examples. So I pulled off some ACT questions for us to look at. And just think of for a minute, use that framework and think about what level are this. Go ahead and pause the video and think about what level of rigor, the academic rigor, these tasks are. And I'm going to give you another couple. Actually, I give you 6, but just you can pause each one and think about what they are. But I just pulled these questions randomly from an ACT test. And again, think about the level of academic rigor. And then here's the last set. So here's something I want you to think about. If you want to increase the academic rigor of your classroom, because typically when I talk to teachers and I find out, we look at their assessments and we talk about the items that they give their assessments, and typically they're either memorization or they're procedures without connections. But you go to the ACT, and what you probably realized from looking at these 6 problems is that the ACT is asking them, the problems on the ACT are asking them to make implicit connections or explicit connections and reason differently. So, you have students who are doing very well in your classes, and then they take the ACT and they come back to you and they tell you, I didn't do very well. Well, because they haven't been prepared to do well. And it's no slight. It's just we're not asking them a level of rigor of questions that we need to ask them in order for them to be successful on the ACT. So one of the things when I work with teachers, one of the first things I have them do is go get an ACT book and let's find some questions that pertain to the content that you're teaching. And let's teach students up to that level of rigor and not rely and focus just living in the memorization and procedures without connections world, because it does make a difference, and you'll see your students' test scores rise. There's some challenges initially, but it does make a difference.